Okay, so now we're still going to be writing linear functions, but we're going to be doing it from a graph. So if you remember, we're going to be doing slope, but I'm going to still continue using the word rate of change because we're going to be doing it from graphs that have some that are related to real life, okay? So I want you to make sure that you still use rate of change. We're going to do rise over run at one point, and then I'll do slope formula in another, just to give you a kind of, joggle your memory on which one it was from ninth grade, okay? All right, my y-intercept is going to be where it crosses the y-axis, so I'm going to go ahead and just draw a yellow dot right here so we can see it. So it's 20. That's what my y-intercept is going to be. All right, let's go ahead and use a different color to do my rise over run. Let's see if you remember what we talked about in ninth grade year, because I've taught most of y'all, but not all of y'all in ninth grade year. You're sliding through the graph until you reach the corner of another box. That is where you're going to put your other dot, and that is where you're going to do your rise over run. So we go up and then over. So I started from 20 and I went to 40, so that's the difference of, let me erase that real quick. This is 2. Okay. It's 20, and then it went from 0 to 2, because even though it's not right here, it's 0, otherwise it would have put something there. This is 2. So 20 divided by 2 is 10. So the rate of change is 10, and we go in and we look here, and I'm tilting my head so I could read it. Number of wooden boxes assembled. So 10 boxes assembled. Oof. 10 boxes per hour. And then the y-intercept was 20. So they started with 20 boxes. Started. Okay? So that means that the equation is going to be y equals 10x plus 20. Hit submit and go on to the next page. Okay, Sheila's graph of data can, Missy is not reading it right. Sheila's graph of data from her last 115-mile trip home is shown below. What equation best represents the remaining distance as a function of time? Okay, let's look for her y-intercept, which we can look at the graph and read the problem. She started at 115. So we can put y equals 115. All right, let's see if we can find some good dots. Right here, there's 1. And if I keep sliding down, find another one right there. So I draw my box. And that's at 1.5, because it's 1 and 2, and it's halfway in between 1 and 2, so that's 1.5. So it went down from 80, so it went down negative 80, and 1.5 to 5. We subtract those, that would be 3.5. And we divide those. So let me get my calculator real quick. So 80 divided by 3.5. Let me erase that and see if that was a good. Let's use the 115 and the 5 just to make sure we get the right numbers. Because I know, like, I see it that is going through, but I know that some of us would say it wasn't. So let's just do the x and the y-intercept. So this is the y-intercept, and that's the distance away from her home that she was traveling. She was 150 miles away from home. It took her 5 hours to get home. That's what the x-intercept is, how long it took her to get home. So we would do 115 divided by 5, and that's a negative 115. 5 goes into 11 2 times, and then the 15 is 3. So minus 23x. All right, let's go to this side. This one is starting at 0, so that's the y-intercept. So this isn't about going home. This is about how much distance the train is going to travel. So of course it starts at 0. It's not going to start some distance away. You're starting from the, is it called train barn? I'm not sure. No, bus barn is where the buses are, but I'm not sure what you call where the trains are, but train station, maybe? Yeah, I don't know. But that's where they're starting at. All right, let's go through the line. Again, this one's close, but we want to make sure we get where it crosses. But I think this one's the closest, if not this one up here. Let's start right here. Let's see if that's good enough. So I went up 200, and it went over 3. Okay. So we don't want to leave it as fractions. In 9th grade, we left most of it in fractions when we were talking about graphs, but when we're talking about word problems, we want to do the decimal for it. So y equals, it's 0 for the y-intercept, so we don't need to put the 0. So we're going to do 200 over 3 x, or because we want the decimal, it would be 66.6 repeating x. Now we're just going to practice with regular graphs. We're not going to talk about the rate, things like that. Like for instance, on this one, the rate would be distance per hour. This one was this is mile per hour and mile per hour because they're talking about speed. But on here, we don't have a label for the y. We don't have a label for the x. So when you don't have labeled, you just say per unit. Okay. But I want to just talk about how this graph is going up. Right, and it's going to continue to go up, so it only has an a y-intercept. This one has a y-intercept, is going down. At one point, the arrow means it's going to go down and reach the x-axis, but not right now. So right now, it doesn't have an x-intercept, versus this one is going to keep going up and up and up. It's never going to reach the x-intercept because it's increasing. Okay, sometimes increasing functions will not have an x-intercept. Sometimes. We don't always want to say never because we never know the type of situation that it's going to be talking about. So we started at 200. We follow the line. This one looks okay. All right. So we decide what the rise over the run is. Up 100 over 20. So y equals 200 plus 100 divided by 20 is 5x. This one right here is at 200. This one's here, so that's 150. That's 50 that it went down, and then went over to 10. So when I divide them, I'm going to get negative 5. So y equals negative 5x plus 200. All right, what I want to take a minute right now is for you to look and see how I wrote these two equations. Is there a difference? The difference is in the location of the x. Okay. One of them is on the back and one of them is in the front. And that's okay. All right. Remember, we talked about how this can be y equals mx plus b, which is what is written in green. But it can also be y equals b plus mx. Okay, that's the second way. So again, they mean the same. Y equals mx plus b is the way the green one is written. Or it could be y equals b plus mx, which is what the orange or yellow color is called, okay? It's all right. They mean the same thing. You still know which one the b is because it's the one where it starts at, okay? Where either the amount of money you had in the savings, how far away you are from your house before you start, the amount of money you had to put into your business. That's your y-intercept, okay? Versus the rate of change is what's changing over time. It's changing by adding 5 every time, or it's changing by taking away 5 every time. Okay, submit. All right, so you have a quiz. This is 4 questions. The first one was only 1 question. That's a total of 5. Make sure that you answer them and don't skip it because your quiz and completing your notes are your daily grade. So that's 2 daily grades per week and 1 major grade, which is what I'm going to be putting up in day 3.